Mukherjee.
I'm Compton.
And I'm Dustin Coha.
And we've made the Dwobble, which works by moving your hands and feet to make some noise. We were inspired to make this because we wanted to make the human being the instrument and just make some music out of motion.
As a quick overview of the components, here we have the workshop at the top of our control box, which controls making the sounds and changing different aspects of the sound. Inside of our control handles, we have IMUs, which are responsible for recording the movements and telling the controller when certain movements are made, and also potentiometers, which through variable resistance can control different aspects of the sound, as we'll go into later. Inside the box, we also have two Arduinos, which handle different aspects of the brains of our project. One of them is responsible for receiving data from the IMUs and performing gesture recognition, while the other one is responsible for communicating directly with the workshop in certain areas. We also have a breadboard, which contains the majority of our electrical components, including switching mechanisms using MOSFETs to control the tones on the workshop, as well as a multiplexer, which handles the communication between all four of the IMUs. The Arduinos are able to be powered by two 9-volt batteries, but unfortunately the workshop itself does have to be hooked up to a wall power supply at this time. The first piece of functionality with the Dwobble is to actually play notes. This is accomplished using 4 separate IMUs. 2 of them are located in hand modules and 2 of them are located on foot modules. Each IMU is capable of perceiving accelerations in 3 directions. These accelerations are sent to the Arduinos, where code processes the accelerations and recognizes gestures in each of those 3 directions. Each gesture is then mapped to a note, which is sent back to the Arduino to tell the workshop to play. As you can see, motions correlate to notes.
Each handle of the Dwobble is a potentiometer, which acts as a voltage divider, so we can control the volume, and we can also control the pitch.
We've also built in an arpeggiator, which increases the frequency of the pitch produced by the workshop incrementally based off of preset intervals. So it sounds a bit like this. It's triggered by inverting the handles.
A few of the things we had to design for this project were the laser cut enclosure for our work set and the electronics. We also 3D printed a handle with the volume knob and IMU for your hands, and also a container which contains the IMU which go around your feet.
Thank you very much to everybody who helped put this entire event together despite of COVID. We had a lot of fun making our device and we hope you enjoyed as well. Thank you.